Okay, let's go on to 3.6, adding and subtracting polynomials. So this first question here says model each polynomial with algebra tiles. So let's go ahead and do that. I have 2 positive x squareds I have minus 5 x's. So let's add 5 negative x's. And then I have 3 positive little small blocks. So normally my negative ones, I would put them down here below, but I don't have very much space, so I didn't want to do that. But you know what? Let's just do that. No big deal. Excuse me. There we go. And this next one, you know what? I changed my mind. Let's just keep them up here even though they're negative. No big deal. Let's go on to the next one. I have 1 positive x squared. Oh, must have something caught in my throat. 3 positive x's. And 2 negative 1s. Okay. In this question down here, they say simplify 2x squared minus 5x plus 3 plus x squared plus 3x minus 2 using algebra tiles. So check this out. Those are the exact same as the questions I just modeled before using algebra tiles, right? So I'm going to take those algebra tiles, and I'm actually just going to put them there. And I'll say that it's this first set of algebra tiles plus this second set of algebra tiles. And then I can go ahead and group like terms. So I'll group up all of my x squareds. And then I have plus 3 positive x's. And you know what? Now I am going to put these minus 5 x's down below. So that way I can create my 0 pairs. And I have plus 3 of the 1s and minus 2 of the 1s. So let's go ahead and create my 0 pairs. There's 1, 2, 3, 1, 2. And it looks like my final equation is going to be 3x squared minus 2x plus 1. Now they're asking me to simplify it using a pencil and paper, so numbers and no algebra tiles. So I'm going to do the exact same thing. I'm just going to get rid of my brackets. So you see up here in this first step, I didn't have any brackets around both of my equations, even though I was using algebra tiles. No brackets. I'm going to do that exact same thing here. I'm just going to get rid of my brackets. And that way I can group up my like terms. Oh, that's not a good color. Maybe this green might be better. So let's group up our like terms. And now let's simplify. So 3x squared minus 2x plus 1. That's exactly the same thing as what I got with algebra tiles. So again, the whole goal is that you can use algebra tiles if you need to, but then if you don't, once you start getting a little bit more proficient, you develop your skill level, you start doing it without algebra tiles. Let's try each one of these. So again, I'm going to get rid of my brackets in this first step. I'll identify my like terms. Now remember, when you identify your like terms, you want to make sure you also highlight the sign that's in front of your term, because that gets carried forward with your term. And now I can group them up, and I can simplify. So negative x minus another 5x will be negative 6x. Negative 2 plus 3 is going to be plus 1. Let's do this next one over here. So again, get rid of my brackets. Let's identify my like terms. And let's actually group them up. I was going to say let's simplify, but I haven't yet grouped them up. And now let's simplify. So 3x squared plus x squared is 4x squared. 2x minus 5x is going to be minus 3x. And negative 3 plus 4 is going to be positive 1. Okay, let's keep going. Write an expression for the perimeter of the following figures. Simplify the expression. So the perimeter of any shape is just 2 times the length plus 2 times the width. Actually, let me rephrase that. Not any shape. Any four-sided shape is going to be 2 times one of the sides plus 2 times the other side. In this case, I just use L and W because we have a rectangle. That's typically what we're comfortable with. Now check this out. I know what my length and width are. This is actually my width, this whole equation here. And this is actually my length, this whole equation here. So what I can actually do is, in my perimeter equation, I can take my length and I can substitute it in. And I can take my width, which is 3x plus 5, and instead of putting w, I can substitute in 3x plus 5 in the place of w, just like that. So I had some equations for my length and my width, and I plugged them or substituted them into my equation. That's going to be a really important, let's just say, tool in your math problem solving box. You guys are going to do a lot of substituting as you keep going into the upper grades, so grade 10, 11, 12. It's a fundamental skill. All right, let's keep going. So we haven't talked about distributing yet, but now's a good chance just to introduce the topic. So you see how I have a 2 in front of this bracket? If I want to get rid of the brackets, I actually have to do something called distributing. So I have to take this 2 and I have to distribute it to each one of my terms that's inside of the brackets. And what that means is I actually take the 2 and I multiply it by everything inside of the brackets. So 2x gets multiplied by 2 and 3 gets multiplied by 2. Now, I have another case of distributing with my second bracketed term. So that 2 is going to have to get distributed to the 3x, and it's also going to have to get distributed to the 5. In my next step, I can take care of all of that multiplication. So 2 times 2x is 4x. 2 times 3 is 6. 2 times 3x is 6x. And 2 times 5 is 10. Now I can identify my like terms, and I can group up my like terms. And now I can simplify. So my perimeter for this shape can be found using the following equation. So my perimeter is 10x plus 10. And so if they give me a value of x, if the question gives me a value of x, I'll be able to figure out what my perimeter is. So I think that's a good place to stop. Why don't you guys try coming up with an equation for the perimeter of shape B, and then we'll take it up in the next video.